actually don't need these. I have teenagers at home, and I lecture to classes full of 100 undergraduates, so I'm well accustomed to bellowing as needed. I'll try not to bellow here. So what we're about is, my volume down. What we're about here is to look at firewall configurations in PCS and determine whether or not the rule sets that you have out there are doing what it is that you really want. Now, a PCS can be compromised in a variety of ways, and considering the last speaker, notice I'm stamping my foot right here with the last speaker's quiz question coming up. And one of the ways is an infection through an external media, and Rob went through how the configurator is doing that through a USB drive. You can carry it into a place just like that, or you can have someone that you trust on the inside that you should not be trusting. That's another way in. Lots of direct access to PCSs through modems and wireless and all sorts of access points that people tend not to think about but are there for sure. But the one that we're really interested in here is access through the enterprise network. And just to give you an example of this, in April 8th, there was a report in the Wall Street Journal that I'm sure that most of you have heard of, if didn't read it itself, that indicated that intelligence agencies thought that there was some foreign penetration of power grid PCSs. Now, I assure you that those foreign penetrations did not come in through USBs and probably didn't come through malicious insiders. Unlikely they came through modem and wireless, and more probably than not, they came in through the outside. Because PCSs do not live in isolation. They live in enterprise networks, as you know. So here's a graphic of sort of a prototypical PCS system. And there's the PCS is down here, and you will note that there's a firewall right there that's protecting the PCS from everything else, and something that's called the demilitarized zone. That's sort of a buffer between the PCS and other things including the corporate network right here, the corporate network right here, and the big bad internet right there. There are firewalls sprinkled up throughout this architecture here, and here, and here, and they're the first line of defense that one has against traffic coming in from the outside trying to get to your PCS. And as the first line of defense, then it's incumbent upon us to do a really good job of making sure that it's doing what it is that we want to do. So that means we need to configure those firewalls appropriately to do that. And it's well documented that problems with configuring firewalls are ubiquitous. A study done by Wohl 3 or 4 years ago, and in that study showed that 70 or 80% of the firewall rule sets that they looked at had problems in them. Those were just individual firewall rule sets. They weren't doing what it was that the configurers really intended. Now, there are some best practices that have been published by smart people saying you want to architect your enterprise, your PCS enterprise, in a certain way, and this reflects some of that with having some DMZs. There are also some recommendations in that say this is what you ought to be doing with your firewall rule sets. And so the kinds of things that, that these best practices suggest, and these are pulled out of on this report, is that your basic assumption within a firewall is that you specify the things that ought to be able to go through. And if you don't specify that, then you should say no. So there's a default of deny. And that the firewall rule should be specific in what they're allowing through in both the IP address and port specific. In the TCP, UDP, you can put wildcards, you can put ranges in these things. And it's saying, don't do that. Which says that traffic should terminate in some of these DMZs. It says that traffic should definitely be prohibited from transiting directly from the control network to the corporate network and back. In other words, you want to use the DMZ as a buffer zone so that information from the PCS gets parked, data historians or something, in the DMZ, and is retrieved by the corporate network. You don't have a straight-through connection. Another one is that any protocol that you're using in the control network, be it Modbus or DMP3 or something like that, should not be allowed between the DMZ and the corporate network. And so one way of trying to prohibit connections is to make sure that you have different protocols on both sides of the DMZ. So, things that you ought to have in your network. The problem is, how can you check that? These are all English written best practices recommendations. How can you look at a big, ugly, complicated, nasty network and determine whether or not it's doing what it is that you want it to do? So the one question that we've been addressing is how can we take these best practices and express them in a form that's machine checkable, so that it's not interpreted by a human, but is interpreted by a machine. And if we can do that, then how do we go to that network and determine whether the implementation of your policy violates any of these rules that you have specified? So that's a problem. Increasingly, you're having to deal with demonstrating compliance with various standards, and one suspects there'll be more of those in the future rather than less. How can you demonstrate? How can you argue? How can you prove to someone that your configuration, that your system is meeting the compliance that you're required to comply with? And the solution that we're going to talk about and we'll demonstrate later is something that we call the access policy tool. So let's zero in on this business of a global policy, which will be a machine checkable form of the kinds of best practices rules that we highlighted before. The approach that we've taken with our tool is to view a global policy rule in very much the same way as one views a firewall rule. With a firewall rule, you have a particular point in the network, a packet comes in, you have a list of rules in that firewall. And a rule in the firewall will indicate a set of places the packet might come from, a set of places the packet might go to, in terms of IP addresses, the ports that it might have come from, and the ports that it might go to, and also the protocol that's being used. And there's kind of netcode magic that's used to express these things in a very compact form. But the key thing is that in that firewall rule, it's saying this is a description of where the packet is coming from and where a packet is going to, and what protocol is being carried, but right here in the network. And what happens in a firewall is when a packet shows up, then the firewall essentially is going down its list in linear order. Does this packet match the first rule that I've got in terms of, is it coming from the set of source addresses that the first rule talks about? And is it going to one of the sets of the destination addresses that the rule is talking about? And is the packet carrying the protocol that this rule talks about? And if it doesn't, then it says, shrugs, and it says, I'll try another one. And so it goes next in the list. And so it goes down the list until it finds a rule that matches. And then that rule will say whether to drop the packet, or to allow the packet, or to send a note back to whoever sent the packet that says, you ain't passing through here, Jack. All right, so those are the three options that happen. So now in a global policy, we're going to take that same sort of philosophy of specifying the source and specifying the destination and specifying the protocol, but two different things, or at least two different things. One is that we're not going to point at a particular place in the network and say, we're applying this policy here. This is a policy of making a connection over the entire network. So we're not making it spot specific. Another thing that's different is that we allow completely general sets of sources and destinations. Whereas in a firewall rule set, you use this netcode business, which allows, for example, to have a rule that could allow a packet being generated by a rogue that's taken an IP address that's assigned but not used inside of one network and get it through. With the global policy, we can be more specific. And then finally, in the specification of the global policy, we make no assumptions about particular orders in which the global rules are expressed. They are declarative. They say, these are the rules, which can allow for some conflicts, and they're conflict resolution rules. So to give you an example, so here's a best practice that says, a recommendation that traffic should be permitted from transiting directly from the control network to the corporate network and vice versa. And here are some kinds of rules that implement that. Since this is a presumption of denying unless it's explicitly said, then we'll say over here, here's the set of all the hosts within the PCS, and we should allow them, if they're anything that's destined in PCS. So that's a rule of connectivity that should be allowed. Or we should say that any traffic that comes out of the PCS should be allowed within this DMZ. And likewise, we can make the same sort of rules here. But with the default of denying what that's going to prohibit, since we haven't said that traffic from here can go to there, then if there was any traffic that was detected that went from here to there, then it would be flagged. It would be in violation of the rule. So we have a tool that takes the firewall rule sets from all of the devices. It discovers the topology of the network based on those rule sets, and then generates all possible flows that might go through that network, and for every possible flow that goes through the network, determines whether or not that flow is in violation of the global policy. And if it is, then it will flag it, and the tool will highlight what the violation is. So you can see this in the demonstration. It's got a nice graphical user interface where these blue things here refer to networks, and the red things here refer to firewalls, and the triangle things here refer to switches. And you can, through the graphical interface, investigate things. You can go to a firewall and see what rules are there. You can go and see what the global policies that you're implementing are. You can run the analysis to determine what violations are, and then go through, and the tool will highlight the paths that are in violation, the rules that are being violated, and will do an analysis and point at the rules that are most often involved in those violations. So it's helping the user to identify where the problems are in the network. So we have been working with 2 industrial partners on this, which has been, I just can't tell you how beneficial these interactions have been for us, in that these people have real networks with real hair on it, and that has forced us to go and do things with the tool and deal with things in the tool that we sort of hoped we weren't going to have to, but we did have to. So things like having authenticated traffic, things like having NATs, things like having double homed or dual home NATs. We were doing fine until we discovered in one of the systems that we were analyzing that they were using routing statements. And so all of a sudden there was some added level of complexity of having to reach further out into cyberspace to find the networks in the topology discovery phase. So these interactions are going swimmingly. This partner is intending to use APT as a checker every night, to run it, to take the rule sets and analyze them and see if anything untoward, unintended had been introduced and left there, which caused the network's posture to be in violation. And so we're working with them and found some interesting things, and we're developing what the global policies ought to be for them. The second partner has a much smaller set of firewalls. That one has 70, this one has 6, I think, but a very interesting network architecture with kind of some backups that are all intertwined in interesting ways, and we're working with them to make sure that's all going as it ought to. And so that's been, as I say, beneficial for us, and we hope for the partners as well. So to summarize, this technology that we've been developing helps address the problem of verifying that the rule sets that you have in your PCS adhere to global policy that encodes best practices. We have benefited greatly from working with 2 major energy companies to make sure that we can address the needs that they have. And this thing is very nearly available. We're intending to be able to license it in June 2009.